Welcome to Homework Lib.
For statement 1, for a fixed set of observations, taking the limit as a approaches 0 in the prior in A gives the same posterior as in B. Well, in Bayesian inference, when alpha approaches 0, it often corresponds to having a very uninformative or flat prior, which means the prior becomes less influential and the posterior distribution becomes dominated by the likelihood based on the observations. If the prior in part B is flat or uninformative or closer to that than the prior in A, then as alpha approaches 0 in A, the two posteriors could indeed become the same because the prior in A would be less relevant, and the posterior would be primarily driven by the likelihood, which would be the same in both cases. So the first statement is likely true, given these assumptions. So of your three, because I don't have the full information, I'm saying that that first statement is likely true. For the second statement, for a fixed set of observations taking the limit as alpha approaches 3 in the prior and A gives the same posterior as in B, well, if A equals 3 or alpha equals 3 in the prior for A means the prior is still informative as compared to the flat prior. The resulting posterior would likely still reflect this prior information. In general, unless the prior in B is also similarly informative or structured, taking alpha approaches 3 would not necessarily result in the same posterior in both A and B. So this statement is, I'm going to say, likely false. Because having an alpha being equal to 3, depending on what that implies about the prior, generally won't lead to the same posterior unless B has a similar prior structure. The third statement, assuming the true parameter A, as we have more and more observations, the two posterior distributions will converge to having the same mean. Well, as the number of observations increases, the influence of the prior diminishes in Bayesian inference, and the posterior distribution becomes more concentrated around the true parameter value driven by the likelihood. With enough data, both A and B will converge to a posterior distribution centered on the true value of a parameter, assuming the model and likelihood are well specified. So I would say that that one is true. I'm going to say likely true, very likely true, probably true, and the middle one probably false.